This is section 8.4, solving logarithmic equations. Our objective today is I can solve logarithmic equations and inequalities. In the first example, it says to solve each logarithmic equation. And the way that we're going to do this, we're going to think about what do we know how to do? Well, in the last section, we learned how to rewrite our logarithmic equations in exponential form. So that's what we're going to start off doing. So on example A, we know that we can rewrite this as 36 to the power of 3 over 2 equals x. Now, we don't need to make this any harder than we have to, so when we're looking at this, we have 36 to the power of 3 over 2 equals x. We can go ahead and actually just put that directly into our calculator. Make sure when you put that into your calculator, you have 36, and most of you will use a caret button. That brings it to the power, and then you're going to want to make sure you put the 3 divided by 2 in parentheses so that it gives you the correct answer. And for your final answer, you should end up with 216. In example B, we're going to do the same type of thing. So first we'll rewrite it as 9 to the power of 3 over 2 equals x. And then we'll go ahead and put that into our calculator as well, just like we did on the first example. And you should end up with 27. On the third example, same type of thing, 16 raised to the power of 5 over 2, which equals x. And then if we type that in, we're going to end up with 1024. With the property of equality for log functions, we can have log b of x equals log b of y. And that's going to mean that x equals y. And if x equals y, then log b of x equals log b of y. And you're going to see a little bit more of what that means when we go over the examples. So in these examples, we're solving the logarithmic equations. Now what's really nice about these, our property says if we have a log with the same small number, we can get rid of them. So, since we have log 2 on the left-hand side of x squared minus 4 and log 2 of 3x on the right-hand side, we can go ahead and cancel out those log 2's on each side. So we're going to be left with x squared minus 4 equals 3x. And this is using that property of equality. So now we're just going to be solving for x. I'm going to go ahead and move everything to the left-hand side. So I'm going to subtract 3x onto both sides. So that I have x squared minus 3x minus 4 equals 0. Now, you guys have solved these before using factoring, so that's what we're going to use. We're going to go ahead and create our big X, negative 4 on top, negative 3 on the bottom. And we want two numbers that multiply to negative 4 and add to negative 3. So that's going to be negative 4 and 1. So our factors are going to be x minus 4 and x plus 1. So if we set both of those factors equal to 0, we're going to end up with x equals 4 and x equals negative 1. And we will want to go ahead and check those and solve them, put them back into the equation. So if we went ahead and plugged our 4 in, we'd have log 2 of 4 squared minus 4. 4 squared would give us 16. 16 minus 4 is 12. So on the left-hand side, we'd have log 2 of 12. If we look at the right-hand side, we'd have log 2 of 3 times 4, which is 12. So we'd have log 2 of 12 on both sides. So we know that x equals 4 is a solution. We then want to check the negative 1. If we plugged the negative 1 in on the left side, we'd have negative 1 squared, which is 1. 1 minus 4 is negative 3. So we'd have log 2 of negative 3. On the right-hand side, if we plugged in negative 1, we'd have log 2 of 3 times negative 1, which is negative 3. So on both sides, we'd have log 2 of negative 3. So we know that negative 1 is also a solution. Looking at our second example, we're going to do the same thing. In this case, we have log 3 on both sides, so we can go ahead and get rid of those. So then we're left with x squared minus 15 equals 2x. I'm going to subtract my 2x onto both sides, so I have x squared minus 2x minus 15 equals 0. Again, I want to solve here, so I'm going to do big X. Negative 15 is on top, negative 2 is on bottom. I want two numbers that multiply to negative 15 and add to negative 2. So I'm going to have negative 5 and 3. So my factors are x minus 5 and x plus 3. And if I solve for x on both of those, I'm going to end up with x equals 5 and x equals negative 3. Again, we have to check these to see if they work. So if we plug the 5 in, on the left-hand side, we'd have 5 squared, which is 25, and 25 minus 15 is going to give us 10. So we'd have log 3 of 10. On the other side, if we plug the 5 in, we would also end up with log 3 of 10. So we know that x equals 5 is a solution. And then we want to check negative 3. If we plug in negative 3 on the left-hand side, we're going to end up with 9 minus 15, which gives us negative 6. And then if we plug in negative 3 on the right-hand side, we'll also end up with negative 6, so both sides would give us log 3 of negative 6. So we know that negative 3 is going to be a solution as well. Our property of inequality for log functions states that if b is greater than 1, x is positive, and log b of x is greater than y, then x is going to be greater than b to the power of y. And if b is greater than 1, x is positive, and log b of x is less than y, then 0 is going to be less than x, which is going to be less than b to the power of y. So looking at our first example, we have log 3 of x is greater than 4. So we want to use our first property to look at this because our log section is greater than just our plain value. So using this, we know that we can go ahead and rewrite this as x is greater than 3 to the power of 4. So now we can go ahead and just simplify this. 3 to the 4th power is going to give us 81, so x is going to be greater than 81, which is going to be our final answer. In example G, we have log 4 of x is greater than or equal to 3. So we'll treat this just like f, and we're going to use that property of inequalities to rewrite this. So we're going to write this as x is greater than or equal to 4 to the 3rd power. And we know that 4 to the 3rd power is 64, so I'm just going to simplify this and write it as x is greater than or equal to 64, which will be my final answer. Now in example H, we're going to have to look at that second line in the property of inequality of log functions section. Because we have our log section, which is going to be less than our plain number. So if I go to rewrite this, I'm going to rewrite it a little bit differently. I'm going to have 0 is less than x, which is less than our b to the power of y in this case is going to be 2 to the 4th. So if I go ahead and simplify this, I know that 2 to the 4th gives me 16, so 0 is less than x, which is less than 16, or x is between 0 and 16 is going to be my final answer.